Hi all. Now we'll write a program in order to find the factors of a given number. So what would be the difference from the other videos that we have here is we'll try to do it in optimized way, and also we'll try to solve an edge case which is present there. So first we'll try to write the source code in a brute force way. So just create a folder here, and okay, just create a class and something like find factors. Okay, okay, next. Mm, okay, let me make the screen a little bit larger. So we'll just call the method call, uh, try to call the method from the static method, and we'll just give something like 24 here. Okay, so now we'll just write a method called find factors. So what would be the brute force? The brute force method would be that we would run a loop. Okay, and we would divide the number by 0. Sorry. If n mod I is equal to 0, we would we would increase the count of the number of factors. Okay, that would be something like fact is equal to fact plus 1. Okay, so we'll initialize the counter here too, and fact is equal to fact count. We will put it as similarly. We'll change it here. Okay, and at the end of the loop we will return the fact count. We'll just check how many factors are there for 24. Okay, when we run this program, and we'll get a number of factors, and it will be around 8 factors that are there. So now we need to optimize this program so such that we reduce the number of iterations that are required. So one way that we can reduce the number of iterations is that we can make this as less than or equal to n by 2, or we can also use something like sqr, square root of something, square root of n also we can take. So how we get that is, I'll explain how we are writing n by 2 there, or square root of n. So when you're writing factors for 24, it can be written as like this: 1 and 24, next to 12, next is 3. 3 goes 8 times in 24. Next it will be 4 into 6. Next it will be 6 into 4. Okay, next it will be 8 into 3. Next it will be 12 into 2, and it will be 24 into 1. So what is happening here is that after a certain point of time, the factors get repeated. See the highlighted ones, the same thing will be present from here actually again. So in order to avoid the repetition of factors, we can derive something as n by 2, and you can find it out on Google how n by 2 is achieved there. So now what we'll do is we'll just change it. as we have changed the condition to n by 2, and each has, for each iteration it has two factors. So instead of using, I mean, instead of increasing the iteration by 1, we will be increasing the iteration by 2 actually. Okay, fact count is equal to fact count plus 2. Okay, so there is some edge case scenario here where we have to consider actually. So for that edge case scenario, we might need to change this one from n by 2 to number of iterations actually. These iterations actually we can actually, I mean, in order to solve the edge case scenario, we need to actually iterate it by finding the square root of the given number where we have, for which we have to find the factors. So it will be something like iterations is equal to sqrt. Just a minute, I just need to. Okay, we should use the math library, math.sqrt of the number, and we need to convert into an integer. Okay, so this iterations has to be used as this here. Okay, now the special case scenario will be this 100 where the factors will be 100, similarly 250, and similarly it will go on like this. So there is a scenario where these both are equal. So we if you add 2 here, then we will get the wrong number of factors. So in order to avoid this one, we have a special condition, and that condition will be, I mentioned here. See, this is, if you consider this side as I and this as n by I, n by I will be, n will be the number for which we have to find the number of factors, and I will be the factor here. So if you do like this, I and n by I, the, the condition is I should not be equal to n by I. Then only we can actually mention this as factors, fact count plus 2. So we'll write that condition here to handle the special edge case scenario. Okay, this will be, okay, I not equal to n by I. So then only we will count it as, then only we will increase the counter by 2, else we'll increase the counter by only 1. Okay, so now let's hope we'll get the right answer here. Running the program. So we're getting 9 factors, which is 100. For 100, do we have 9 factors? Let's check. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Right. So these are all repeating ones. So we have the right answer. So this actually is the correct program, where if you have to optimize the program for writing the number of factors, for printing the number of factors, and also in order to handle an edge case scenario for perfect squares. This 100 is a perfect squares where 10 square is equal to 100. Similarly for 1000 or for other perfect squares, we have to use this condition. So this actually is an optimized way for writing the for printing the number of factors, and also handles the edge case scenario. Thank you, and I'll come up with the next class very soon.